All right. Oh, yeah. Safe. All right. Now, there's big differences between local Privest on Linux versus Windows. If you want to talk about Linux Privest, talk to Adam. Usually when we're doing red team exercises, I break him in, and then he rapes the network, pretty much. So while they both share the standard amount of kernel-level vulnerabilities, even to Privest, there are several things that we see as being different in our reviews, that you're more likely to come across a fully patched Windows system than you are a fully patched Linux box. So during several recent Linux reviews, the standard build of the organization was only patched up to a 2010 level. And if you know anything about Linux Privest, that leaves you open to a skew of TAVIS vulnerabilities, more or less. Whereas on Windows, the patch timeframes are much shorter. We might get a month before a server gets patched, and anything critical is generally rolled out within a week. So I'd like to say that Privest on Linux is easy, but I changed it to say that it's fairly common. So even if you don't have TAVIS in a box that you can pull out to root your server, and you find that they are patched to his latest full disclosure post, you can still usually find some SUID bin lying somewhere that's vulnerable to a polluted parameter or some environment string being passed through to it. If neither of those methods pan out, there's always, you've got some sort of symlink vulnerability or other race condition. And even if they don't work, there are always some badly coded management, admin, Perl scripts lying somewhere running at high privileges. And if you look at any commercial grade Linux box within a large organization, you'll see a ton of defaultly installed management apps running as root, open ports, just waiting for Adam to come along and have his way with, should we say. When we get to the Windows land, we've got to work hard. Still, you can pull out TAVIS. It must be really handy to have him on your team. And recently, there's a slew of the kernel vulnerabilities parsing font files, because for some reason Microsoft decided that the kernel is where they want to parse fonts. Good stuff. If you're into Metasploit, one single command will run half a dozen different Privests dating back for the last 5 years, and will give you a root shell. However, we don't get the whole binaries set to run under higher privileges that we can control by passing in our path or our environment settings. So where does that leave us? So I've been interested in Windows Privest for a long time, because obviously it's the second part of a compromise. Once you get onto a box, you want to get your domain admin going. And when you have a picture of your domain admin creds, pillaging the network, put that in a report, the customer never has any issue paying you. Or if you're trying to hide your tracks, it's usually very helpful too. So you Google for Windows Privest, and you'll find, you get a whole bunch of current vulnerable driver, I/O control, this. Currently, like I said, you've got the font vulnerabilities, that, or TAVIS has got some NT4 through to 2K8 vulnerability that he's still yet to release. And you Google and you come up with something like this. How do you escalate your privileges? Oh, it's quite simple. You run the @ command and you tell it to be interactive, and that gives you a system prompt. Yeah. So I'm pretty sure that if I went to Adam Middlestorm, who works for me, and I said, oh, look at this. As root on Linux, you run this program and it gives you root, he would just laugh at me like the penguin is. Now, is that really all we've got for Windows? You can Privest from admin to system. Here's another fine example of a native Privest exploit for Windows. This guy even wrote a nice batch file with comments. But again, it's escalating from an already privileged account just up to a higher privileged account. To system. You're going from admin to system, and admin is in control of the box anyway. This guy then got all excited and said, oh, in the command prompt you run Explorer and you get system in your taskbar telling you that you're system, and you can run your games as system. And then there's more and more and more. I think that's the official source of Windows Privest. So sticky keys, right? You can replace a binary in the system32 folder. How are you going to do that? You're going to be admin. Oh, right, okay. However, saying that, I did use that recently to break into a box that I'd forgotten the credentials for. But I mean, I had physical access. I whacked out the drive and put it in another machine and just, modified it like that. And if you've got physical access, you've already won. And then there was an advisory published earlier this year with the whole, if you can put a program.exe in the root drive of C drive, any service or system application that doesn't wrap their execution path in double quotes, the search order will first look for a C drive program, C drive program.exe. Well, that's great. That hasn't worked since Windows 2000. And their advisory even went on to say that under default conditions, it's not possible and this won't work. But if they've really screwed up their permission settings, then you can do this. Well, that's a really big if. And in an engagement where we've got a user account on a box, it's of absolutely no use at all. So the aim of this talk was originally to have some good research, but obviously we had another baby, and that didn't happen. So what I will discuss, though, is some of the techniques that we've used over the last years in Citrix environments, RDP sessions, kiosks, locked workstations, and post-exploitation, i.e. you run your Metasploit latest IE browser exploit, you've got a shell, now what? There's no 0 days, sorry. In fact, there's no memory corruption at all, so no heap blinks this time, everyone can relax. Just stock standard, what you would do when you get on a box. So we'll talk about escalating from user to higher user, network admin to local system, admin, domain admin, and if there's time, we'll talk about IE sandbox escaping, integrity levels. It gets no easier than this. I had to do a Citrix job once. They had to do it after hours, which, I hate working to begin with, but after hours is even worse. I got there, Citrix desktop, 5 minutes later I got a command prompt, 2 minutes later I find a file in the root directory from an OEM unintended install, clear text admin password, run as service is enabled, you're now running as admin. To me, that is much more useful than if you can replace a binary in System32, then, Similar thing with the sysprep tool for OEM, vendor, deployment agencies, unattended installs. You'll either find it as clear text or you'll find it as base64 encoded. Once again, you find something like that, that's gold. Windows doesn't have grep, it has some sort of fine string tool, which is more or less useless. But that one string, search the entire drive for any text files, XML, config files with a password in it. Awesome. Any installed FTP clients, mail clients, VNC, even RDP files, these are all easily decrypted, reversed, NIR soft, Russian password recovery toolset galore. Probably run it in a VM, not on your native box. So that's looking at the files. Now you're looking in the registry. So VNC Again. You'll either find clear text or easily decrypted VNC passwords in the registry. And if you look in the auto login key, which is readable by any user, you might find the clear text auto login password. Now you might be asking yourself, why is that useful? If I'm already logged in, I must know the password. But in some kiosks or VDI clients where they automatically log you in to the thin client, and then there's an interface to log you further into the network. Well, if you can escape the thin client, read that key, then you've got a local account, which is normally an administrator account, on that thin client, which is going to be the same on every other client around the organization. Also in that key, also that registry tree, the keys for the default shell and any WinInit scripts that are going to be run. And I'll come back to why they could be useful later on. If you don't have access to run the regedit tool, because there are group policies to prevent it, and you haven't managed to upload your tool suite yet, just use the reg command line tool. A couple other minor ones, you might find some SNMP parameters or some PuTTY proxy credentials in the clear text. And again, just traverse the entire registry looking for password or username or user pass, etc. I mean, you get the idea. And for those of you that don't know what the clip tool is, real handy command line tool to pipe anything, any output directly to the clipboard. So if you're working in a Citrix environment and you want to bring it back to yours, run that. It'll put it in the clipboard. It'll come across the Citrix channel, and then you just paste it back into your local machine. Moving on from those, extremely easy and still better than replacing a binary in the System32 directory. On Windows XP in 2003, always look in the taskbar for anything running as system. As we can see here, there's an Ultras agent that's running as system. Click your heart galore, get a file dialog, find command.exe, get a command.exe prompt as system. There is no patch for that. It's a design flaw, and it's not going away. In 2004, I gave a presentation here about shadow attacks. That's not going away either on XP in 2003. I mean, it's not going to work on your Vista, Windows 7, or 2K8. But on anything running a system with a window, you can attack it, either with the GUI or from the command line. Anything with a list view, a tree view, an edit box, a rich text box, will all give you system-level access from a non-privileged account. And stuff like this still works. So we can see in the command line, hopefully you can read that. Where as a test user, which is my test user, obviously, trying to get a directory listing from the administrator documents and settings. It says file not found because they got too lazy and couldn't do a denied. You bring up utility manager that's running a system. They fixed all the shadow attacks against it, but you can still send it an lbdir message and get directory listings as system. So from a normal user account, you can now read directories and potentially files from anywhere in the system. So that's XP 2K3. Now we're going to talk about XP and Windows 7, which is going to apply to 2K3 or 2K8 by default. So by default, the program files directory prohibits an unprivileged user from creating files or writing to it. Obviously, if we could override a binary in the program files directory, we could easily Trojan any application, and when you get the admin to come and click on something, Explorer, Internet Explorer, they're running your application. So that's fine, and it's highly rare to find a writable location under program files. But it does happen. So this is a PC Anywhere 10 install, and those two binaries for PC Anywhere have everyone given full privilege. So you can jump into that directory, overwrite that binary with Trojan, old school, 20 years ago, Trojan chaining attack. Now on newly created directories, although a user can't write to the root of the folder, any newly created directories will by default inherit those permissions that are shown on the screen there. So on Windows XP, the users group by default inherits file append data and file write data. This means that any user can add to an existing file and can create new files, even though the owner, as shown there, is the administrator. So on Windows 7, a similar thing occurs, but it's actually worse, is that authenticated users get create, append, delete, which is enough to take control of any binary outside of the program files directory. Now, the authenticated users is a special group, which is any user that authenticates to that box is automatically put into the authenticated users. So any unprivileged user that logs in is automatically able to append data, create new files, and delete any file in an unprotected directory, which is by default anything created post-install. So as you can see, the directory here is owned by Brett, who's an admin, and another user, test user, has created a file there. So how can this be a problem, and how can we use that for PrivEsc? I haven't seen the best of them. So Metasploit had to release a vulnerability advisory and patch for Metasploit because someone alerted them that by default the Metasploit install, which was outside of the program files directory, was world writable. So any user could Trojan Metasploit, and then when the next guy came along to go and attack someone else, he got attacked himself. So, and if you ever get a chance to see a talk on attacks against vulnerability assessment or vulnerability attack tools, I highly recommend going to it. It is awesome to know that when someone using Metasploit attacks you, that you can chain back down there and take over their Ruby session. Well, not anymore, but you could. So here's a stock Windows 7 box. You can see Brett admin creates an admin file with his contents in a directory outside of program files, and you'd expect it to be safe, right? An admin creates a file, how can someone go and overwrite it? Here's test user, there's no special tricks here, he just overwrites the file. And the reason being, like I said, authenticated users get file append, file write, and delete, by default, inherited. And it's awesome when you do an assignment and you break into an IIS box and they've moved the default data drive to the D drive, which they've labeled data or whatever they want to, and define that the IIS directories are inherited these weak permissions, and you can just overwrite their script files. So access check, that's a tool by sysinternals, and be easily used to scour an entire directory entire system for directories with weak permissions and files with weak permissions. So that's really helpful as far as PrivEsc goes. We can override a binary, such as PC Anywhere or Metasploit, and then wait for another user to log in, or depending on your situation, you bring up the admin and say, oh, my Metasploit's not working anymore. Can you come and try it out for me? And so he RDPs in, runs Metasploit, is running your Trojan under his privileges. Not so good for me, because the times when we do engagements and we do ring up the help desk, they just ignore us. So we need something a bit more silent, less interactive. Although I guess we could bring up the admin and say, hey, we've compromised your box, why don't you go check it out? So we want something that runs when the user logs in, and hopefully everyone knows about auto runs. Microsoft that purchased sysinternals still supply all these awesome tools for use, and if you're at KiwiCon and saw James's talk, a lot of the tools that he uses are for sysinternals, like Procmon, Proc Explorer, auto runs. So this will tell us everything that runs when the user logs in, whether it's through the auto runs key, or whether it's a service or a printer driver or an Explorer hook-in context menu. And what we're looking for here is something that sits in a directory outside of program files. We know that we can't get to program files. We've checked it. They don't have PC Anywhere or Metasploit. But we came across this one quite often, a couple of weeks back even. Is that BG Info is a tool that displays, creates a desktop showing you the system status, your host name and IP address, and just in case you don't know where you're logged into. It's actually quite helpful. And so it's set up in the run key to run every time someone logs in. And it's sitting in the BG Info directory. Oh, that's the bigger for those at the back. And it's sitting in a BG Info directory. So we know by default it's going to have weak permissions. So we go and check it out. So checking out the permissions on the executable, it tells us that we can't overwrite it. So either the installer or the admin has prevented users or authenticated users from overwriting the binary directly. However, we still have permission to create a file or append data into that directory. And there are other ways to circumvent execution if you can create a file in the same directory as a binary. Another sysinternals tool, process monitor. So we know they're running bginfo, so we download bginfo, we run it up in our test lab, we run up process monitor and see what it's doing. Specifically interested in the DLLs that it loads, and primarily those outside of the system32 directory. So the way that the load library call works in this instance is they've done a load library riched32 to load up the riched32 DLL. It will initially look in the current directory, which is bginfo, and then it will look in system32, etc. So all we need to do is create our attack DLL, call it riched32, put it in the same directory, which a normal user has all the rights to do, and then every time bginfo runs, they too can do calculations. And that will run every time any user logs into that box. So if it's a shared environment or if it's a Citrix desktop primarily, then all of a sudden, everyone that logs in is running your Trojan, and you're just hoping that one of them logs in with domain creds or more privileges than you. Or you ring up the admin and say, oh man, my calculator's showing up, log in. Apparently, it's supposed to be a scientific calculator. There's various other more complicated tricks you can do, but easy works well. You can set up a .local, so you go bginfo.local, and you set that to configure it to load DLLs from a different location. So you can actually prevent the loading of kernel 32, user 32, NTDLL from the system32 directory. Or you can set up for .NET applications, you can set up a .manifest, similar type thing. And depending on the search path, they might have installed an application that has appended, is installed into a directory outside of program files, like Perl, which installs by default, C drive Perl or whatever, and then it puts itself in the path. Well, if it puts itself in the front of the path, and you put an application or a DLL or a binary in the Perl directory, then it will get pulled up first before it gets to where it's supposed to go. Always pays to check the scheduled tasks. Oh, actually, I'll go back 20 slides. It always pays to make sure that you can't actually overwrite a binary in system32, because if you can do that, that's a good win, but highly unlikely. Always pays to check the system tasks. Now, there's a bit of a problem here that as a normal user, you can't actually run the at command, but you can still go and look in the Windows tasks directory to see what the task names are, but you can't pull out the execution path of them. If you're doing a paid consultancy gig and you're doing a review where you have both an admin account and a normal user account, log in as the admin account, check out the tasks, find the paths, see if any of those point to a weak directory. Again, we had an assignment where there was a task that would run at midnight under a domain account. So from a normal user, we edited the batch file that was being called, charged the client until midnight while we waited, and it ran, and we got a domain account from that. No, we don't actually charge like that. But, yeah, I'm drinking water here, man, come on. So you can't run at, you can run scheduled tasks or shit tasks, however you want to pronounce it, which will show you your tasks or the tasks under a user account. And you can still get to comp management. I mean, even if you can't right mouse click on computer and that, or you can't run MMC, you can start comp management and view the tasks through there. Or wait for the next Stuxnet. Yeah, that's the one. So the way the Stuxnet task vulnerability worked was scheduled tasks under, Vista and above, basically an XML file that specifies, amongst other things, the date, time to run, how regular, the binary to run, and in text format, because it's XML, the account to run under. So if it's a task that runs under the system account, it'll have in the XML file whatever, user / local system. So the way that Stuxnet worked was the guy that found the vulnerability realized that internally a CRC check of the XML file was kept, and when the task was run, that CRC value was compared. So they determined that, well, we can create a task as a user, because every user can create a task to run as himself, and then we can edit that task, that scheduled job, and we'll just change it from being user to being local system, and then we'll pad it out to get a CRC collision. And that's how the Stuxnet local Prevesc task vulnerability worked. I'm pretty sure they've done something to fix that, like CRC'd it twice or something. Under the computer manager or auto runs, check out the services. I mean, most services run as systems, so if you find a weakness here, that's an easy Prevesc from user. What you're specifically looking for here, which we don't often come across, but we did a few months back, you're looking for orphaned binaries. So if there's a service in there, I didn't actually have the best example, but if you imagine that highlighted line there wasn't pointing to System 32, but it was actually pointing to C drive HP services, where HP had installed their admin services, set up the service to run, and then someone had come along and just deleted the directory. So when the system starts, the operating system, Windows, tries to load that service from that location that no longer exists. By default, a user can create directories in C drive. So if we recreate that directory structure, putting our binary in there, next time the service wants to start, it will run our service. Again, access check can be used to find weak services, specifically looking for ones that provide the service change config. If you find a service that allows you to do that, then you can reconfigure the service yourself to run arbitrary binary. So that's XP SP3. There's no 0 days there, but I mean, that's a power user. And if you're a power user, then you're already privileged to some extent. So basically, a power user can reconfigure the DCOM launch service to run their binary, to run it as local system, power user to local system. This is XP SP1, and these are the couple that were patched a few years ago, is that Microsoft provided service all access to the authenticated users group for those two services, Universal Plug and Play and SSDB serve. So any user that logs into an XP SP1 box at the time could reconfigure those. So looking for service change config, but if you don't get service change config, you might get write DAC, which is the access control. If you get that, well, you can just reconfigure the access control to give yourself service change config. If you get write owner, then you can just become the owner and then reconfigure it. Generic write, inherit service change config, and generic all, of course, is everything. To control the service in Windows, use the SC tool. That one's just doing a query. And for those of you that take away the slides, or those are the commands that you would use to reconfigure the service, stop it, start it up again. Adding a user called hacks. If you're ever looking at any large AD servers and you find users in there like hacks or Haxer or Haxorata, it's always surprising to find out that they have valid accounts. I remember years ago, and I started at a company, and this was right back at the beginning, and I was unauthorized looking at their systems for them. And I found a user called Peter Pan, and I was like, well, that's definitely a hacker, right? I mean, someone's got on Peter Pan. It was just a Chinese guy that, when he came to New Zealand, had called himself Peter Pan. You get similar permission issues in the registry, on registry keys. Excuse me. So MS 1111 was a key that was writable by any user that was then read by a kernel service, leading to an exploitable condition. You must read Caesar's work if you haven't already. His vulnerability on the service tracing key, again, writable by any user, and then services would read that key to determine if they needed to enable tracing and where to enable tracing to. So he used that to do a token impersonation attack, which I'm going to talk about shortly. Or it was a registry symlink vulnerability where a normal user could write to a restricted key in a different registry tree, leading to an exploitable condition. Processes, threads, handles, pipes, shared memory. All of these things can have weak DACLs, or weak permissions. If you get a user who has write access to a process, well, you just inject your code, remote create thread. You can steal process tokens, hijack handles for writing to files, and long pipes are always long. There's the syntax. Access check with a question mark, right? That will give you all the syntax you need to bash up a script that will audit a system for weak permissions on directories, files, services, processes, etc. And as I mentioned just previously with Caesar's work on token impersonation, every process obviously has an identity token, which is the user that started that process or privilege level that he's running under. They have locked it down, but still some accounts have the SE impersonate privilege, primarily ASP.NET and the IWAM computer name. So if you compromise an IIS box and you can create an ASPX file, you can use that to steal a service local system token to privesc from ASP.NET user to local system. And all the local service and network service, which are restricted user accounts. Microsoft, clued up and realized that they can't run everything under local system, so they created these two accounts. But these two accounts have the impersonate privilege and can therefore be, if you compromise, for example, the SNMPT service, and it's running under networks, the network service account. From there, you can Google Caesar's token kidnapping 1, 2, and 3, and apply his great knowledge to privesc from a restricted account straight to local system. If you're going to look up this information, there was another paper by MWR Info Security, who also created the tool Incognito, which is now included as part of Metasploit for doing these exact attacks. And churrasco, which I think is barbecued beef or something, if I'm not mistaken. Yeah. And then there was another one, which I can't pronounce either, were Caesar's proof of concept tools. Basically, you upload them to an IIS server, you run them, you get local system. Great stuff. So if you've compromised a box and you find that you can create a file, so you've compromised a box through some exploit that's giving you a normal user account, and a normal user account can't do token impersonation, so you can't use these attacks. But you find that under the IIS web root, there's an images directory, to allow people to upload images, and the normal user has write access to that. Or you can write an ASPX file to that, and then come back in through IIS. So you jump from your normal user, you half do the attack, you come back in through the IIS user, and then you use a token impersonation to privesc up to local system. So it's not from, normal user to root. It's just a couple of steps. And the first impersonate name pipe or name pipe token impersonation attack that I came across was back in 2003 by @stake. And the wonderful thing about these methods is that it's actually functionality abuse. It's not a vulnerability. I mean, they're not going to fix it because it's how the architecture is designed. I mean, network services, IWAM account, they have to be able to impersonate things, other accounts. ASP.NET, when it does forms authentication, it's impersonating you. So they can't take away those privileges. They just got to keep Caesar quiet, I guess. So the way it works in a real basic manner, that's a horrible color, I apologize for that, is you get a process with SE impersonate, like a network service, and you get the target service that you're going to attack, which is running as local system, let's say SQL Server. You get the process or your ASP script to start up a named pipe, we'll call it MOFO for lack of a better name. You send a request to the target service. So if it was SQL Server, we'd send it, We could use a SQL injection vulnerability to send it an XP directory command, which is available to any authenticated SQL account. So, it's not an SA account. The XP directory will connect back to the name pipe, and then the name pipe or our process says, awesome, I'm going to impersonate you. And our process is now running as local system. And that's the attack in some terrible colors. So like I said, the guy from MWR Info Security, Luke Jennings, when he released his white paper, he created Incognito. So Incognito is slightly different to Caesar's Churrasco attack in that Incognito doesn't use the name pipe impersonation. You have to be running as admin. So we're now talking, as the title says, admin to domain account. Because admin is all fine on a local box, but what are you going to do? You want to get that domain admin account, you want to get to the AD server. So you run Incognito as an admin, and it will run through all the running processes and pulling out all the impersonation or delegation tokens that are available. So if it's a shared VDI environment or a Citrix server, you might be logged in, Bob might be logged in, local domain admin might be logged in, or you can just run Incognito, say I want to be domain admin, steal his token. In a similar attack, if you're an administrator, you already have the privileges to open domain admin's running process and just inject, create a new memory section, inject shellcode with write process memory and create remote thread and be up and running. But Incognito, and more specifically the Metasploit module for it, allows you to run it in a seamless manner. There's also WCE, Windows Credential Editor, which is the new and improved pass the hash for Windows. Again, you have to be running as admin. It queries LSASS, which is a privileged service, retrieves the hashes for all the logged in people or those that have recently been logged in. And you can use it to, again, select, I want to be Bob, or if you're that way inclined, Susie, or domain admin. And it actually modifies your hash in memory. And then you just go and do whatever you want as that new user. So grab a domain account hash and travel. That's how they all work these days. You compromise someone's workstation with a spear phishing attack. You take over their workstation. You coerce a domain admin into connecting to the workstation. You steal their hash and you just pillage. So that's a few techniques for Windows Priv-esque in a standard situation. But nowadays, when you compromise an organization through an IE vulnerability, you're going to end up in a sandbox environment. And so it's still privileged escalation, but same user. So the way the IE sandbox works is it sets different integrity levels for the different running processes. There are 6 different levels, starting at untrusted, low, medium, which is what you normally run everything as, high, which is what happens when you click run as administrator, system, and protected. So a process that's running as low integrity level, it can't write to anywhere protected at a higher integrity level. So it can't write to a file or folder. Yeah, yes, it does. You can still read anything. So like a low integrity process can still read, user documents, can still open sockets and access the clipboard. It's only allowed to write to specific registry locations, and it's got its own temporary data store. So the idea is that it's a restricted account so that when IE8 or 9, latest VON comes out, the attacker can't actually get any persistent hold on the system. They can still extract data, but they can't get any persistence there. Anything running from a low integrity location will always, so if you put a binary and the temp file is low, it will run under the low integrity level. One of the key points with the process is when you click on something in IE, like you want to open a PDF, IE will look up the registry key for elevation policy and determine if there's a setting in there which will tell it which integrity level to run the new process. So WinWord, which is a trusted application, will run as medium level. Command EXE you can't run at all. So for the next few slides, there's only half a dozen or so, we're going to assume that IE has already been compromised. The attacker has migrated to a low IL process running in the sandbox. You know, the attacker, during our engagement, wants to get out. There were a couple of released issues with this a few years ago. Scape, before he got made to be quiet, released a vulnerability in the issue that they were passing back a handle during the creation of new processes that he managed to snarf and could then use that handle to start new processes. There's another semi-convoluted method which works in particular circumstances where you compromise IE and then your exploit sets up a web server on the local host and then you tell IE to connect back to the web server, so you're compromising it again using the same exploit. The more recent issues, which are slightly more interesting, the Stephen Fewer pwn to own, he found out that if you were running as a low integrity process and you created a binary and you assigned it the untrusted integrity process, you would bypass the Microsoft check because their check was if integrity level equals IL low. So no, but I'm untrusted. Sweet. And another one a few months ago was Ruben, who determined that in that registry tree with the settings for applications like Adobe and WinWord, there's one presentation host. He found out that a low integrity process could write an XP application. It would run with full trust. There's numerous other ones in there. Good viewing for those that are interested in it. The one that we're going to look at in particular is one for Java. The slide's missing. There's one for Java when a JNLP file is loaded, and Java will run out of process as a medium integrity level. So we're going to say that the attacker compromises an IE box, he uploads his exploit files, he injects into IE and tells IE to start a new process, Java. IE will say, look up on its list, say, yeah, I'll start Java with a medium integrity level, and we still get sad kitty. The problem being that when we compromise the box and we're running in low integrity, we can only write files into the low integrity temp files, temp directory, and anything started from there will inherit the low integrity flag. So here we've started netcat from the temp low directory, and you can see down the bottom it's got low. So the way to get around that is you tell your Java process to copy your files out of the low temporary directory and just put them into the temp directory and then execute it from there. Enough talking. I've got, with any luck, 2 seconds. So we have a couple of netcat listeners here. We have a Windows 7 VM here. We have an exploit here. This is the exploit for the NTUDC enable, which is the normal user can write to a registry key that is then read by the system, leading to a vulnerability. He says hit start, right? So I've run the exploit. I've told it to start a command prompt, and we can see that my mouse is going crazy. We can see that that command prompt is running as system. If you can't see that, you'll just have to take my word for it, which is good because it's a reliable working exploit. Awesome. Okay, I've got another command exe over here. I've started this command exe, and I've told it to run as, where is it? Here, as low integrity. So I'm emulating being inside IE low integrity process. I try and run the exploit from there. and nothing happens, it fails. Because the way that exploit works is it writes, like I said, to a registry key that a normal user can, but the low integrity process doesn't have access to write to that key. Oops. Just to confirm, we can't write to the temp directory. We're going to say we've uploaded or the attacker has uploaded their exploit scripts into the low integrity directory, and he's going to run his exploit. It's going to do its thing, and with any luck, he says, how do I start that one? Great thing about live demos, you've got to make sure they work. There we go. Okay, so what that escape exploit has done is it's escaped the low integrity sandbox and connected back to me. And now, so we'll just take my word for it that this is that VM. And we are now going to run that exploit, the privilege escalation exploit, and we're going to tell it to connect back to this other one, and that's how you escape IE sandbox and get out our system. And that is the end of the presentation.